I'm going to talk a little bit about peer-to-peer testing. So I'm Matthias. I go by Macintosh on GitHub. I also write a lot of peer-to-peer stuff. And when you write peer-to-peer stuff, I feel like you run into this problem a lot where it's really hard to test it. And what we normally do is, what I normally do at least, is I write a bunch of modules, and then I write a bunch of tape tests or market tests or whatever your preferred portion is. And then you test all the modules like that, which is really good. You get actually really good coverage like that. But then at some point, since it's peer-to-peer, we want to do network stuff, and everything becomes really, really tricky. So I've basically been spending a lot of time recently trying to figure out how can we make that situation better. Basically automated testing where we still do network stuff like integration tests. So, and also I did not make any slides because I was fixing a bug. Anyways, so has anybody ever heard about Mininet? Cool. It's one of those things I learned about 2 months ago, and now I just pretend that I always known about it since forever. It's basically a small framework, a library, that allows you to very easily set up virtual networking on Linux. And virtual networking, if you're not familiar with it, is just like a way to basically pretend to have a bunch of network cards in your computer, and they all behave like normal networks. But with the added benefit of you being able to define your topologies and like all the settings with the network cards and stuff like that. So kind of like lightweight VM networks. And the cool thing, since we're on Linux, we also have very simple Linux containers. So we can kind of like compose that in together into just making very easy, simple, testable things. So if I just, what's it called? Mininet. Oh, what was? Man, I typed that so much. That's the only way I know how to like copy that thing. I just search for. So anyways, that's. And then Danish flag emoji. Oh, okay, this is like a ton of good data here. Yeah, so it's this project basically. So somebody linked me to this, and I was like, this is actually really good for setting up virtual networks, which is actually what you want for if you wanted to do like actual testing with integration tests and stuff like that, instead of having a ton of computers, virtual networking is a really good solution. So I read up on this, and I found out there's pretty good Python support for this. There's a Python library. So what I did was I wrote a module called Mininet, because that was available on NPM also. And it's a node module that just, in JavaScript, that just writes Python behind the scenes. So basically, what you can do in Mininet is you can do cool stuff like this, where you require it, and you can say, I want to get a switch, like a normal switch you have at home. And then you can say, I want to create a host, and a host is just a Mininet way of like a computer, basically, a small container. And then you can do cool stuff like link your hosts with a switch, or link a host with a host, like basically build your topology. Think of it like as the network cables, how should they go into things. And then you can spawn stuff on the host. So in this simple example, I'm just spawning a node server, and then I have some message passing logic where you can send messages out from the server and react to it. So that part is really, really cool. So basically, if you have a server like this down here, you can spawn that into the container, and it gets this, you can require this Mininet host thing to message your host script, which is this one up here. So down here, I'll just spin up a server, and when it's listening, I send a message listening, and then in your host, you get a message listening event that you can react to, and there I just try to run curl against it. So that's like a simple test. So let's try that out. It's really easy to use if you're on Ubuntu, which I'm not. So what I did was I have a Ubuntu container. Don't need sudo. I'm just gonna boot up. So just like virtual Ubuntu. So if we go into, I think I have it here. Oh, it's no modules. So here I have that, I don't have the, here's that README. Did I not have the example here? Oh, it's in the folder, that's why. So here I have that, that server you saw from before, and that sample that kind of orchestrates it. So what I can do is I can just run this example, and I'll just run that Mininet server. So down here you can see it says server listening on 10,000 because the server is printing that out, and the server responding, and the thing all coming together. So the cool thing is you can very easily set up these virtual networks just in code without having to worry about a ton of stuff. But this is kind of, I did this and I was like, that's cool, and then I tried to use it and it was really hard. Because it turns out when you do peer-to-peer stuff, you have a ton of servers often, and you have to do a ton of orchestration to like test anything, and I end up having like a ton of bugs in that, and then you end up testing your tests, which is like the most useful thing you can ever do as a programmer. So I started thinking, how can I improve this? And I'm a big fan of Tape. People know what Tape is, or like Tab in general. So it's like a very simple test runner for Node that just allows you to write like linear tests, basically, with basic assertions. So I started thinking, how can I turn this into Tab, or Tab-like experience? And I wrote this cool module called TapeNet, also a cool name, because it's Tape for networks, or Tab for networks. So it's basically a small module that just uses every time I zoom when I record my screen, it takes forever for some reason. It's just a small module that takes the same idea, wraps the Mininet, puts it in a nice little test runner interface. So this is a very simple example where you require a TapeNet, which is just Mininet. You can still make the host and the switches, and you can link them together. And then you can write a small little test here where you have a small description. This one says start a server and connect to it. And then there's this magic function called t.run that just runs a function on a virtual instance. So it actually takes this function and serializes it and sends it to a Linux container that's running in an environment where based on that topology, and then runs that code. And these hosts also act as magic event emitters that you can use to emit events across the virtual instances. So it's really easy to set a bunch of stuff up. So what I do here is I run it. I wait for a listening event on the other host because you want to orchestrate something first. And then I try to connect to the other host here and then see if I get a response from it. And down here, I spin up another server. And I create a server and just reply back. Right? So very simple example. And the cool thing about doing it this way is that if you have your server file like this, you can just run it. And I'll just run it as a normal tape test, gives you tape output. And it's really easy to test. And you saw how fast it is. It's doing a ton of stuff behind the scenes. It's like spawning Python, converting JavaScript to Python, setting up virtual networks, and like, yeah, crazy. It's like writing 8,000 global variables in Python also, but everything works. So that's really cool. And there's a ton of extra fun stuff here where topologies all of a sudden turn out to be really easy because you want to test a bunch of different topologies, because if you've ever done anything with peer-to-peer, which I think people in here have, you'll find out that all your crazy bugs comes from people's crazy topologies. And a topology, because this is all software, it's really easy because it's just a JavaScript function. So I have a topology here I call basic. That's just like make a switch, make a bunch of hosts and link them together. You can usually do that just as a function. I have another one here I used to test a ton, where it's just a linear topology or serial topology where you have a host connected to a host that's connected to a host, like a Christmas chain lights. You can use that to test a ton of stuff. And what's cool about the Mininet is that, oh, that's another module, is that you have really awesome options like when you link things together, you can say cool things like, I want to use a 10 megabyte uplink on this one, but I want to have 100 milliseconds delay, and actually give me 10% package loss because I want to see how my thing behaves there. And again, you can just do this in software, and you can just run that as a tape test. So as an actual example of where we started using this a ton was in the DAT project, which I work on. We started writing a bunch of integration tests. So here's one, for example, that is very simple. It's an integration test that just tests multicast DNS. and it just literally just runs 2 instances, and they try 2 hosts and try to find each other using multicastiness. And I literally fixed 20 bugs after running this test, because you find out that when you run an actual network, things don't behave as you expect. And just a ton of stuff like that. So it's really, really easy. So that was all I wanted to share. So if you want to try out setting up tests, this is a really good way. The main downside is that it only works on Linux. So it'd be really cool if somebody wanted to help out to get this running in a Docker container or something like that, so we can use it on Mac. That's it. Thank you.
Any questions?
Oh yeah, sure.
Can you set up maps in Mininet?
Yeah, you can. It's really, really powerful. It's one of those Linux things that's really annoying, because the hardest thing about Mininet is installing it, because you have to clone a repo and call like 4 different scripts, and it turns out the one on GitHub is not the right tag, and so that's why a Docker container just takes all that pain away. So I just use a systemd container for mine, but you can totally do that. But it's actually also surprisingly useful to run it without a NAT and just run it self-contained to see how your thing behaves. Like multicastiness on Linux behaves extremely differently if you have a NAT or not for some reason. That's why I find all my bugs. Yeah. Any other questions? Cool. Thank you.